Okay, continuing factoring. These types of factoring, these types of polynomials that we're going to factor are ones that do not have a value of 1 as the leading coefficient. Or we say that a is not 1. Okay, so leading coefficient is not 1 is the same as a is not 1. And we say a, if you remember, the standard form is ax squared plus bx plus c. All right? So if you notice, a is the leader. And so these examples are going to have leading coefficient that's bigger than 1. This is page 4 of the factoring note sheet. And this is all that we're going to do in this video is these 3 examples. Now, these can sometimes be a little bit tricky, and sometimes students take the easy way out and say it's prime. But don't fall into that trap. This isn't always prime situations. More often than not, these polynomials can be factored. All right, so here, notice that the examples we just factored in the last video all had 1 as the leading coefficient. What happens when the leading coefficient of the trinomial is more than 1? We're still going to use trial and error. And not only are we still going to use trial and error, but we're still going to use our rules for the signs, which helps us out a little bit. It's just we have more combinations to test, really. All right, so I'm going to move up my paper. And we're going to fill in this part of the notes. So if I look at this example, number 4a, it says factor 5x squared plus 17x subtract 12. The leading coefficient is 5. Now I need to also consider factors of the first term. Factors of the first term. And, you know, when our leading coefficient is a prime number like 5, it's not that too terrible to do it. It's when the leading coefficient, the a value, is bigger than 1 and it's not a prime number. So if it's some number like 16, then we have even more work to do. But this one's not going to be that bad because the leading coefficient is 5. Yes, it's bigger than 1, but it's a prime number, so it's not too terrible. You have to have a strategy, though. You must strategically place the factors of the first and the last terms, and then you must test the combinations. Must test combinations. All right, so what I always do is, again, I like to list the factors of the leading coefficient and the factors of the constant term, which is the guy on the end. So I'm going to move my paper over so I have this margin. All right? I'm going to set up my 2 binomials. I know my signs are not the same. Excuse me, they're different signs. Different signs, and I know I'm going to subtract products. This then is the sign of the larger product. So larger product is plus. I thought about that. All right, so this side is going to be for my x side. All right, so, you know, I'm looking at my 5x squared. And then over here is my 12. Okay? Now, I don't typically write the x's because I know the x's are going to go in there. So I typically will just write a 5. Okay, well, 5x squared is 1 times 5. You can write it as 1x times 5x. That's the only way to get 5x squared is 1x times 5x. The only way to get 5 is 1 times 5. 12, though. 12 has some different factors, okay? So 1 divides it 12 times. 2 divides it 6 times. 3 divides it 4 times. And I believe those are the only combinations that exist for 12. Now here's where the trial and error comes into play. We've got to figure out what products do we multiply and that when I subtract them, I'm going to get a 17. So sometimes this takes a couple of times to do it. You know, I'm looking like, okay, 1 multiplied with 1 is 1. 5 times 12 is 60. 60 subtract 1 is not 17. So I'm not going to use these two together. Well, what if I reverse it? What if I do 1 times 12 and 5 times 1? Well, this would be 12. Subtract 5 is not 17. So I'm not going to use this pair. It's not working for me. All right, let's figure out 1 and 5 with 2 and 6. Well, let's do 5 times 2 is 10. 6 times 1 is 6. 10 subtract 6 is 4, not 17. That's not going to work. Let's switch them. Let's do 6 times 5 and 2 times 1. Well, this is 30. Subtract 2 is not 17. So again, I can't use that pair. I'm hoping that the last pair works. Okay, remember again, I'm subtracting. Well, look here, if I do 5 times 4, 5 times 4, I get 20. 3 times 1 is 3. And 20 subtract 3 is 17. So there's my pairs. I'm going to do a 5x here and a 1x here. What did I say I multiplied the 5 with? I multiplied the 5 with the 4. See, I underlined them. So I know the 4 has to go over here so that when I do, the multiplication of the outers or the inners, I get that 20. And then, of course, I'm going to place the 3 here because 3 times 1 is 3. 20 subtract 3 is 17. Now I'm going to figure out where the signs go. The larger product has to be plus. 20x is clearly larger than 3x, so that gets the plus, that gets the minus, and I'm done. So again, not too terribly difficult, but it is a little bit more work, and you have to play around with these factors. It's not always going to be this one times this one and this one times this one, or maybe 1 times 3 and 5 times 4. It could be 5 times 3 and 4 times 1. Okay, so there's a lot of combinations that you need to test. All right, we'll do another one together, and then the third one, we'll see if you can do it on your own. All right, so again, I've got a 6, and I've got a 12. I know I'm going to add products, so I've got same signs, and I'm going to add. And both are going to be subtract in my polynomials, in my binomials. They're both going to be minus. But I'll look at that again later. I just want to figure out what are the factors of 6, what are the factors of 12. Well, 6 is either 1 times 6 or 2 times 3, and that's about it. 12 we already saw was 1 times 12, 2 times 6, or 3 times 4. Now, I need to play around with factors, and I'm going to tell you that usually, not always, but usually, when these numbers are pretty close together, it's usually the factors that are closer together on the number line. In other words, 2 and 3 are closer to each other than what 1 and 6 are. 3 and 4 are closer to each other than what 2 and 6 and what 1 and 12 are. So I'm going to try to go for this. That's my strategy in my mind. If this number is not that much bigger than, either the last guy or the first guy, then it's probably the ones that are closer together on the number line. All right, well, let's look. We need to add to 17. Well, look, if I do 2 times 4, I get 8. 3 times 3 is 9. Okay, 3 times 3 is 9. Well, isn't 8 plus 9 17? So there we go. I've got it. Now, remember, this was from my x side, right? So this is 2x and 3x. 3x and 2x. It doesn't matter where you place them. For some reason, I just like the bigger guy first. When it's, the a is bigger than 1. It's just what I do. I don't know. Then I just say to myself, what did I multiply 3? Well, if you underline and circle these, you're going to see it. So the 3 has to go here, and the 4 has to go here. And now you check it. This is 9x. This is 8x. 9x plus 8x is 17x. Signs are the same. They're both minus, minus, minus. Done. Done, done, done. Okay, again, not too terribly difficult, but, you know, start picking up on the little tips and tricks. Again, if this is close to this, then it's probably the factors that are closer together on the number line. All right, you should probably pause the video and try the next problem on your own. All right, hopefully you pause the video. And let's take a look at this last problem. This one's not so bad either because 3 is a prime number. So 3 can only be gotten by doing 1 times 3. 18, however, we've got a little more factors to contend with. We've got a 1 times 18, a 2 times a 9, a 3 times a 6, 7 doesn't go in, 8 doesn't, 9 does, but I already have 9 in the list. So I'm pretty tapped out on the factors of 18. Those are going to be about it. All right, now I'm forced to use 3 and 1. There's no question about it. The signs are the same. And I'm going to add products. And the signs are both plus. All right, I'm going to take a look at that when I'm done at the end. I just wanted to think about it because I absolutely need to know if I'm going to add products or subtract. All right, I'm going to add products, so I got to figure out, well, 29 is a little bit bigger than those. I don't know, maybe it's not 3 and 6. Well, let's try. Here's 18 plus 3 is not 29. Maybe this will work. Maybe these two. Let's look. 9 times 3 is 27. 2 times 1 is 2. 27 and 2 is 29. So again, I multiplied the 9 with the 3, the 2 with the 1, and that worked. When I added them, I did get 29. So now I know it's 3x and 1x. Remember, I had to multiply the 3 with the 9, so that's going to come out here to the end. The other factor was 2, so the 2 goes here. And, you know, you could check it. This is 27x. This is 2x. 27 plus 2 is 29. Signs are the same. They're both plus. So I could fill in my signs now. And notice, these have nothing in common. Neither does that. Okay, so again, trial and error. You got to list your factors, test the combinations. 29, again, was a little bit bigger than 18 and kind of a lot bigger than 3, so we went with the middle guy there. Or just, you know, guess and check with your calculator. Doing the signs last, I think, is helpful. That way you don't have to think about positive numbers with negative numbers, multiplying with those. Again, keep in mind that if you have puzzle worksheets, I'm not interested in the puzzle answer. I'm interested in what work you're showing. So show work on homework and write out the original problem on lined paper. Okay? To get full homework credit. All right, if you have questions, please ask in class. The more you do these, the better practice you're going to get. And I know we're pretty much doing a lesson a day. You will have the holiday break. And I'm not saying that you should spend half of your holiday break doing this. That's not what I'm saying at all. But if you do get bored and you're like, oh boy, I'm really not doing that well with factoring, maybe I should practice some. Maybe I should watch the video again. You got to do what you need to do because, again, I can't impress upon you enough that if you do not know how to factor, you're going to be sunk for the rest of Honors Algebra 2, and I don't want to see that happen to you. So please reach out, come to a Google Meet, post on the homework discussion, or ask me questions in class. Have a great day.